High-pressure cylinders are metal containers designed for storing gases and for dispensing them at high pressure. Think fire extinguishers and oxygen tanks. The contents are often flammable, so the challenge is how to make these often life-saving cylinders safe, yet still easy enough to use. These cylinders are made out of chrome moly, a steel alloy containing chromium and molybdenum. They start with discs that have already been heat-treated at 730 degrees Celsius for 36 hours. Now they go into the first of 5 hot chemical baths that will help the metal flex. After a quick drying period, each disc moves over a die. This process is known as deep drawing because a series of machines will gradually draw out the disc to the shape of a cylinder. A mandrel press begins stretching the metal, applying up to 800 tons of force, the weight of 2 fully loaded jumbo jets. Shaping the cylinder from just one piece of metal means it'll be seamless, and that's a key safety feature. After the disc comes through, steel jaws clamp down on the mandrel and the cylinder slips off. Now another press stretches it even more. This machine applies 250 tons of force to continue forming the walls of the cylinder. That liquid is a coolant to prevent overheating. The cylinder goes through as many as 3 presses, each one stretching it another 60%. This press forms the closed bottom end into a concave shape. That reinforces the base, helping the cylinder withstand up to 1,000 times more pressure than a can of cooking spray. A bandsaw now slices up to 10 centimeters off the other end, which will become the top of the cylinder. Next, a torch heats that end to 982 degrees Celsius for 90 seconds. In a process called hot spinning, a worker then places the cylinder in a device that spins it at 1,000 RPM. As the torch maintains the temperature, the machine shapes the edges of the searing hot metal into a curve. In this way, the machine gradually closes off the top end and shapes 2 rounded areas called the shoulder and neck. Making these areas curved is the best way to contain pressurized gases. Curves spread out the stress on the metal. A sharp corner would focus the stress in one spot. The only exit for gases will be through a valve at the top. Workers then place 18 cylinders in a furnace heated to 900 degrees Celsius. After 90 minutes, a machine then dunks them in a chemical bath to cool for 6 minutes. The cylinders are then reheated to 650 degrees Celsius for 90 minutes, then left to cool for 2 hours. These transitions between hot and cold, a process called tempering, strengthen the metal and make it somewhat flexible. A cutting tool carves open the neck and cuts threads inside it. This provides the best seal when the valve screws into the neck. Workers clean the cylinder's surface using a process called shot blasting. A machine shoots these tiny steel pellets at the cylinders at very high speed. They test the cylinder by filling it with water. Then they seal it off and immerse it in water. The machine then adds more water to the cylinder and gauges how well it withstands the extra pressure. They rinse the inside with hot water, then dry and clean it by blowing in some purified air. Next, a hydraulic press indents the shoulder of the cylinder with legally required markings, such as the manufacturing date and the serial number. A machine then stretches a steel collar over the neck. Another device, called a valver, tightly screws on the valve, creating a leak-proof seal. After a trip to the paint shop, these high-pressure cylinders are ready to be filled and keep it all under control.